55 in base 6. We want to represent it in binary, base 2. I know the hard way to do this. I'm just pausing briefly to wonder if there's an easy way. If there is, my notes will reveal the easy way. Oh, yeah. Okay. I'm glad I looked at my notes. This gets back to this idea that we talked about a lot when we were counting, when we were increasing by 1 or decreasing by 1. In a base 6 system, 5 is the maximum digit. And so this is 1 less than this. It's 1 less than 36. Because, of course, in a base 6 system, this would be the 6 squareds place. This would be the 6's place, and this would be the, oh, Bill Gates, why do you torture me with that glitch? This would be the 1's place. But if I have these two place values filled up, I have 1 less than 36. So that tells me this is a 35 in a base 10 system. So I don't have to do the whole table to sort of, although I kind of did it, but to sort of figure out what is that number. It's kind of like if you were translating from Spanish, if you're an English speaker primarily, and you've got your French friend and your friend who doesn't speak French, maybe your Chinese friend, and you want to translate what your French friend is saying in French to your Chinese friend, you might filter it through. You might hear the French and think of it in English, and then take the English and translate it to Chinese or Mandarin. And so it's kind of like I'm going back to the system I'm most familiar with. I know that's 35, and then I start to think of 35 in a base 2 kind of way, in a binary kind of way. And when I think of binary, I can do it in my head. I'm going to show it I know I've got a 1's place, a 2's place, a 4's place, an 8's, a 16's place, a 32's place, a 64's place. All I'm doing is I'm multiplying by 2 each time, because I know it's 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, etc., etc. But I don't need 64's place if I have, see, I'm looking at the 55 again. This is how tricky this is. I'm looking at 35 is what I should be looking at. I don't need any 64's, but I could sure use a 32. If I want to represent 35, I could definitely use a 32. And then if I've got 32 of my 35, I only need 3 more. So I don't need any 16's, 8's, or 4's, but I could use a 2 and a 1. There's my 3 more. Of course, you could spend as much time as needed to go back through and double check that, but I feel pretty confident that that's correct. It's much longer number, many more digits required, because of course the max digit in a base 2 system is 1. You only have 0's and 1's to work with, where in a base 6 system you have 0's through 5's, 6 values, 6 symbols to represent value in each place.